The topic for discussion in this video lecture is about the building blocks of a robo. So, of course, we know the building block of a robo, one is sensor, the other one is drives, which will be making the robot to move. And here, this is Dr. S. Mohan Lakshmi, Professor and Head, Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology. On completion, the student will be able to explain what are the types of electric motors used in robotics, and they'll be able to explain the design aspects of stepper motor, and they'll be able to explain the components of servo motor. So here we term here as actuator. It is a term used for the mechanism that drives the robotic arm. There are three main types of actuators: electric motors, hydraulic, pneumatic cylinder. Hydraulic and pneumatic actuators, they are generally suited to drive prismatic joints since they produce linear motion directly. Hydraulic and pneumatic actuators are also known as linear actuators. And what we are going to see is about the electric motors, which is suited to drive revolute joint as they produce rotation. And most of the robots use the revolute joint. So coming to the electrical actuators, so this could be a stepping motor, DC motor, AC motor or servo motors. Why we go for these type of actuators or these type of motors? So it has its own advantages. Small size, it is easy to control, and you have a high control accuracy. It can respond fast, it is clean. And coming to the disadvantages, it has a low power output compared to the hydraulic actuators. And coming to the electric motors, these are the most common source of torque which is used for mobility and for manipulation in robotics. The physical principle of all electric motors is that when an electric current is passed through a conductor, normally a coil of wire, which is placed within a magnetic field, a force is exerted on the wire which will make it to move. And what are the components of an electric motor? So these are the principal components. So where you have north and south magnetic poles which will provide a strong magnetic field, and it is made up of bulky ferrous material. So they traditionally form the outer casing of the motor, and collectively it is called as a stator. An armature, which is a cylindrical ferrous core rotating within the stator, and it will carry a large number of windings which is made from one or more conductors. And you have the next component to be a commutator. So this will rotate with the armature, and this consists of copper contacts which is attached to the end of the windings. And obviously the fourth component is a brushes which is in fixed position, and this will be in contact with the rotating commutator contacts. So they carry the direct current to the coils, which will be resulting in the required motion. And as we have discussed, so this diagram shows you the components of an electric motor. So stator, armature, commutator and the brushes. And coming to this electric motors, we have discussed already. So this can be a DC motor, this can be an AC motor, this can be a servo motor. So the DC motor, the stator is a set of fixed permanent magnets which will create a fixed magnetic field, while the rotor carries a current. Through the brushes and commutators, the direction of current is changed continuously, which will make the rotor to rotate continuously. And coming to the AC motor, this is very similar to the DC motor, except that the rotor is a permanent magnet. The stator houses the windings, and all commutators and brushes are eliminated over here. And coming to the servo motor, it is a DC, AC brushless or even stepper motor which will have a feedback mechanism which can be controlled to move at a desired speed. And obviously once you are able to control the speed, you can control the torque. So for a desired angle of rotation, I can move it. So you will be requiring a feedback device to which will send the signal to the controller circuit of the servo motor. to report its angular position and its velocity. And stepper motor. So from the name itself we could guess. So it will make an incremental rotary motion which is required in a robo, and this is achieved through the stepper motors. A stepper motor possesses the ability to move a specified number of revolutions or fraction of a revolution in order to achieve a fixed and consistent angular movement. This is achieved by increasing the number of poles on both rotor and stator. Additionally, a soft magnetic material with many teeth on the rotor and stator multiplies the number of poles, so which we take here as reluctance motor. And this figure illustrates the design of a stepper motor, which is arranged with 4 magnetic poles, which is arranged around a central rotor. So you could see that the teeth on the rotor have a slightly tighter spacing to those on the stator, which ensure that the two sets of teeth are close to each other but not aligned throughout. So movement is achieved when the power is applied for short periods to successive magnets. So first magnet, second, third, fourth, like that. Where pairs of teeth are least offset, the electromagnetic pulse causes alignment and a small rotation is achieved. So you can typically achieve 1 to 2 degree. They have several advantages. These stepper motors, it is directly control can be directly compatible with the digital technology. They can be operated open loop by counting steps with an accuracy of plus or minus 1 step. They can be used as holding devices since they exhibit a high holding torque when the rotor is stationary. Coming to the servo motor. Servo motor, they are special electromechanical devices which will produce precise degrees of rotation. A servo motor, it can be a DC or AC or brushless DC motor, and this is combined with a position sensing device. They are also called control motors as they are involved in controlling a mechanical system. They are used in a closed loop servo system. So this gives you the block diagram of servo system where you can see input, which is there is a feedback loop. So once the error is detected, it gets amplified, it is get corrected, and until the error is eliminated, the output is not shown here. Then once you have the proper degree of movement, then the output is shown. Reference input is sent to the servo amplifier, which will control the speed of the servo motor. A feedback device is mounted on the machine. This is either an encoder or resolver. This device changes mechanical motion into electrical signals and it is used as a feedback. These feedback is sent to the error detector, which will compare the actual operation with that of the reference input. If there is an error, then the error is fed directly to the amplifier, which will be used to make necessary corrections in the control action. In many servo systems, both the velocity and position are monitored. Servo motors provide accurate speed, torque, and have the ability of direction control. Thank you.